Hello and welcome. It's time once again to try to fix something. And today on the workbench I've got a PS4 Pro. And I have it plugged in right now. And I will go ahead and show you that it is dead. Nothing when you press power, nothing when you press eject. And it's kind of hard to tell. Let's look at the back of it. That security label looks like it's been kind of peeled off at one time, maybe stuck back on, I'm not sure. That one there looks like it's been there. So I'm not sure if this thing's been opened up yet or not, but I'm about to open it up and see if we just need a power supply repair or what do we need. So let me get this get the covers off, and then we'll get the power supply out and see what's going on. Okay, I have the top cover off, and this one's going to be a dirty one. And I'm seeing some very small, possibly roach parts. Yeah, I think so. So yeah, that may be quite. Sorry about that. So that may be a teaser for later. Let me get it on apart. All right, I have found a power supply in another dead PS4 Pro around here. That should work. There's one I just pulled out. Do we have any more signs of life now? We do. And there's a disc must be in there because it ejected. Red Dead Redemption 2. Already have one of those. Unfortunately, I have the play disc as well, so I have two play discs. So I still can't play Red Dead Redemption 2. So she's rebooting. We're going to have video. Okay, so we have a power supply to fix, looks like. She's trying to lock. Unlock. Oh, there we go. All right, so she's going to need a nice cleaning. But other than that, we have another power supply to fix. A PS4 Pro supply. I've repaired a few of these, not many. A few. So we will definitely give it a try. This is a 300 P1A. Okay, let's get it inside of the workbench and see what we can do with this monster. Okay, we are inside of the workbench. Ready to take a look at this dead PS4 Pro supply. Need a different Phillips. Yeah. And these things can be difficult. Trying not to break every clasp in it. That's better. Don't believe this one's ever been opened before. Here we are. Okay, finally. Haven't seen any sign of roaches in this one, so. Well, I take that back. Maybe a small amount. You can see that. So yep, the roaches are not totally off the hook yet. And the first thing I want to do is discharge that capacitor so we don't get bit. Oh, I love when the leads tie themselves in a knot. All right, now Nothing. Absolutely nothing. All right, how about let's check a few things. Now my meter's broken suddenly. Okay. Yeah, you're going nuts. Okay. Look at that later. Main fuse is good. Get that screw out of the way before I short something. Trying to remember if these have a secondary fusible resistor or not. There's a small resistor down in there, a small value. Seems good though. Let's just go ahead and see if anything is shorted in here. Checking a few MOSFETs. That looks good. Nothing shorted there. Let's see, there's some, yeah, there's the larger MOSFETs. These look like, this is the one for the power factor corrector, I believe. Which I kind of doubt is going to be shorted, because if it was shorted, the fuse would have blown. If there's a dead short, I mean, something has to give. That's going to be a diode. I'm trying to remember. I guess we need to find out that I don't see anything shorted, anything obvious. Just to make sure, put a meter right across the capacitor here. No, there's no dead short there. So let's get some power to it and just see if we get 5-volt standby. As soon as I find an AC cord. Okay, found one. Wasn't that far away. Okay, yeah, this is powered off right now. Okay, let's give it some AC. Are we getting 5-volt standby? Make sure everything is kind of in the picture if I could. Let's see. So this is, I don't know if I can get on that ground or not. Yeah, I'm not sure if I'm getting it. The pin is kind of recessed up in that connector. Well, this is ground right here, same ground. So it looks like we do not have 5-volt standby. Do we have rectified DC on this capacitor? We do, 160 volts, 159. So our fuse is good, our bridge rectifier is good, our filter cap is good. We've made it to here. Let's see, do we have, let's see, which one of these is the negative side? Nope, so the negative is on this side. Well, I'm trying to stay out of the way of the camera, and it's just not working. I'm putting my probe on the negative of that capacitor, and on this little fusible resistor here. Yeah, so that all looks good. She's just not running. It looks like it has voltages available, but we do not have the 5-volt standby. And of course, you can't have the 12 without the 5. So let me turn this off. Maybe go ahead and discharge this again. Okay. Capacitor is discharged. Let's see. Let me look on the other side of this board. To see what the controller is for the 5-volt standby on this model. Because I don't remember. Oh, it's going to be right there. Well, time to crank up the microscope because I can't see that well to know what that chip is. Oh, this way. Oh, okay, and now we see the burnt leg of a critter. So yeah, I couldn't see that. That's a 5760. I do have those in stock. I am wondering what else he may have popped. Well, like I see a solder ball on top of that resistor right there. That could be from the factory. So maybe he just popped this 5760. Looks kind of like those traces around that area were kind of stressed, doesn't it? Looks like the solder mask has come up from heat. But that MOSFET did not read shorted there. This would be the MOSFET that's being driven by this LD5760 over here. And let me look at this resistor right here. Get it in the shot. Yeah, most likely that one's good. 8201 was at 8.2K. Oh yeah, 8199. So and how about this 1000 ohm right here? Yep. Make sure these two 2.4s in parallel are good, but they look nice and healthy. Should get about 1.2, 1.8. Oh, I need to subtract. Let me null this out on the meter to subtract the lead resistance. There we are, 1.2. So all that looks really good. I'm thinking we just lost an LD5760. Because that's where the roach happened to step. Let me look, 1, 2, 3. Get this in the shot. Stepped on pin 8 of that LD5760. Let me pull up the diagram. Alright, here's the data sheet for the LD5760. You can see this is the one we have without pin 7. Pin 8 is a high voltage connection pin, which, let's see, startup. Okay, that's used for the startup. That'll be connected to the AC in through a resistor usually. See if they got an example here. No example in this one. Thought there might be an example circuit. Oh, here we are. Yeah. So, yeah, off the AC line, you see a diode, and there will be a resistor in series. And this usually, I think it's just used for startup. Once it starts running, it generates voltage from a secondary winding of a transformer and comes back and feeds the supply. But I think internally there's a connection. It charges the capacitor up and slowly, brings it up to, I think it'll tell you when it gets up to a certain point is when it starts running, and then this is meant to keep it running. So sometimes if they want to start and stop, it's because the voltage that maintains the run is not coming up. So, but that's where that bug stepped on, is that high voltage pin. So, all right, let me see if I've got a 5760. I'm pretty sure I do. Well, our LD5760 has been changed. Have we done any good? Let me get a ground down in there. And get on this 5 volts. And let me enable the AC in. No. Oh, yeah, I'm plugged in. So we still have another issue here, right? I've got a ground. There's my 5 volts. Yep, still have a problem. All right, that capacitor is charged now, so I'm going to be very, very careful here. Flip this over. And where is that 5760? Right here. I want to check and see if we're getting any voltage to that high voltage pin. So here's the negative terminal of our main filter cap right here. And let me turn some AC power. AC is back on. And I lost that capacitor already. Okay, right there. What do I have on this pin 8? 1.25 volts. I don't think that's enough to help us. And the VCC pin, well, is pin 6, but there's not going to be anything there because she's not running. Pins 1, 2, 3, 4, 5, 6. Yeah, nothing there. Pin 8. What's on? There's an 8.2K resistor we checked earlier. 100 volts on one side, 1.1 volts on the other. Is that right? Let me check this again. Must not be much current involved in that startup at all because they're going through an 8.2K resistor. 101 volts. Being pulled down to 1.15 volts. And across this filter cap, we have 160 volts. That all looks normal over here. Turn that off. And let me discharge it again. All right, just so we're safe, I want to look at where that comes from. Let me go to continuity mode here. So that may be right though. I'm going to get on the other side of this 8.2K ohm resistor because I think they have it laid out in black ink here. Coming from right there over in the AC input section because it is AC input. Yeah, there's a diode and there's a diode. There's the two diodes that connect to it. Just like they showed on that sample. Let's check those two diodes. I got a feeling they're going to be fine. Oh yeah. So we're getting 100 volts there. And this resistor was good, it said. Yeah. 8.17K. What else does it go to? All right, I've been working on this thing for a little while, and I think I've discovered something. I had tried replacing that LD5760 again with another IC, thinking maybe I got a bad one, you know, out of the box. It happens, and it acted the exact same. That voltage on pin 8 was just like 1 volt, like it was just being pulled down all the time. So I tried another one, and still no change. So I couldn't find anything else open. No resistors open. Everything looked fine. So I got to wondering about these parts that I was using, these 5760s. I had bought, looks like 20 of them, and this was the first time I had used this batch of parts. I had some other ones I had bought previously that I finally used up, and this was the first of the set of 20 that I had tried. And there's the other one. You can see those, that's the two that I had tried. So then I got to looking at my parts, and a DAP41 is pretty much the same thing, I believe. Not 100% on that one, but I had some DAP41, DAP041s. You'll see those used in other PS4 supplies for the 5-volt generation. I put one of those in there. And now, if I flip on my AC and probe right here, 4.88. So yeah, I think I was sold some bad parts, or some fake parts. I don't think those are LD5760s, because they don't act right. I think they are garbage. And I got to make sure I never buy from that vendor again. I know it's been a while. I had those parts a while, and just had not used that batch. Had needed to open up that, that strip of 20. So yeah, garbage parts. Let me see. What I need to. I think this chip will work fine. I need to find some more LD5760s. Let me clean this thing up, and we'll try it out there in the chassis. We are back out in the garage. We've got this PS4 Pro fully reassembled. Our repaired supply is in there. Cleaned it up a lot. New thermal paste. The usual suspects. Clean the Blu-ray drive, something I usually do, to clean the rollers, clean the lens. Let's see if she'll turn on. Clean the fan out. New battery for the to back up the clock. So this thing should be good to go for several years. See where my remote control is here. Here we are. Where's my Red Dead Redemption disc? Red Dead Redemption 2. We'll just see if it'll play some. Try out the old Blu-ray. Forgot to check and see what version of software this was on. Say system information 9.5. Okay, so I'll probably upgrade that to 10.01 and start. So far, looks good, sounds good. I think we're going to have a success here. But yeah, that was a pretty easy one, other than the phony parts apparently that I have received. And I do have some more ordered. I hope they are good, because I hate getting fake parts. I hope that was somewhat entertaining or educational. If it was, please give me a thumbs up, and I will see you in the very next repair. So long for now.